Let us now look at example 4 on page 9. That is about Swiss Lottery, which means 6 out of 42. There are 42 balls numbered from 1 to 42 in an urn, and 6 are drawn randomly without replacement. And the question is, what is the probability of guessing all the 6 numbers right, or of guessing 5 out of the 6 numbers right, or 4 out of the 6 numbers, or just in general k out of the 6 numbers? The idea or model that we're going to use here is that we say the 6 numbers that we have selected, we colored corresponding balls in red. So we have 36 white balls and 6 red balls, and the question is, what is the probability that when 6 balls are drawn from an urn with 36 white and 6 red balls, that we'll get all the 6 red balls? The number of choosing 6 balls out of 42 is 42 choose 6, and to choose just the 6 red ones from in there is exactly 1. So we get 1 over 5.2 million, or 0.00002%, quite a small chance. We can calculate the probability also in a different way by saying the probability that the first ball to be drawn will be red is 6 divided by 42. Then for the second one, it is 5 divided by 41, since there are only 41 balls left and 5 out of them are red. Then 4 divided by 40, and so on. And we have to multiply all these probabilities. The probability of getting 5 numbers correct is the same like the probability of drawing 5 red balls, which means we can choose 5 out of the 6 red balls and 1 out of the 36, and we combine all of them, so we have to multiply it and still divide it by the same number, 42 choose 6. The result is 0.0004%. We can calculate also this probability in a different way by saying, well, the probability that the first chosen ball is red is 6 divided by 42, the second one 5 divided by 41, and so on. The probability that the fifth ball chosen is red is 2 divided by 38, and then the probability that the sixth ball chosen is white is 36 divided by 37. This is the probability that the 5 red balls get chosen first and then the white ball at last, but we don't care about the order, so there are actually 6 choose 5 different orders when the 5 red balls will be chosen, so we have to multiply the whole thing by 6 choose 5. The probability of getting 4 correct ones is the same like that 4 red balls would be chosen, and we see the number of possibilities for getting 4 red balls is 6 choose 4. Then the number of possibilities of getting 2 white balls out of the 36 is 36 choose 2. We have to multiply these two, and we get in the end a probability of 0.18%, so still far below a percent. Again, we can calculate this probability in a different way by saying the probability that the first chosen will be a red one is 6 divided by 42, the second one 5 divided by 41, the third one 4 divided by 40, then times 3 divided by 39, and then that the fifth one will be a white one is 36 divided by 38, and that the sixth one will be a white one is then 35 divided by 37. This is just if we get them in the order, first the 4 red ones and then the 2 white ones. Again, we're not interested in the order, so there are 6 choose 4 possibilities when to choose the white ones. So we have to multiply by that factor. By now we can write down the general formula, the probability that k out of the 42 numbers are guessed correctly, which is just 6 choose k times 36 choose 6 minus k divided by 46 choose 6. Using this formula, we can calculate now the values for all possible values of correct guesses, and we see that even the probability of having 3 guesses correct is less than 3%.